Okay. Right, so it's a big lesson, that's why it's a double lesson. So we won't do any, it's unlikely we'll get this topic, it's unlikely we'll do another topic today, because for those people who have studied this before, there's a lot to do in circular motion, okay? Or motion in a circle, whatever you want to call it. So if you can write that down, we'll start, circular motion, or motion in a circle. Yeah, you got that? Yeah. So as you can guess from the name, it's movement in a circle. But there's quite a lot involved in that. Okay. Right, so before we even talk about movement in a circle, we have to talk about the names of the different parts of a circle. So, who knows what the orb is called? Radius, yeah. And the theta? The theta? The angle. But the S? Not quite, because circumference is the whole thing. Yeah, but there's a word for that.
Word?
Oh yeah, one word for that.
One word?
Yes, arc, yeah. So, a circle. Theta is the angle, R is the radius, and S is the arc length. Please write those names down and draw the circle. Arc. Yeah. Got that? Yeah. Arc, yeah. Okay. What are you doing in maths class at the moment? Logs, okay. You haven't done trigonometry yet? No. That's, I think, the next chapter. Right, continuing. So, in physics, when we're dealing with motion in a circle, we do not use degrees. In fact, there's another unit which you will learn about in math class, but maybe somebody knows it, called the radian. We use a new unit known as the radian. And what precisely is a radian? So you have in a circle 360 degrees. We don't really use degrees in physics. We use this thing called a radian. Does anybody know how much a radian is, roughly? How many degrees? Yeah, but if you were to convert it into degrees, 1 radian is roughly how much? How much? But decimal, roughly. How much? Oh, no. Bigger than that. Do you know? Does anybody know? What is it, Bruce? The radiant is about 57.3 degrees. That's how much a radiant is. Roughly. Really. Trust me. So, the reason this unit is important will be explained in maths class. And if you are wondering, the 57.3, where did I get that? In fact, it's exactly 180 over pi. For physics, it's important because the formulas we'll use only work when we use radians. So for the lesson today, all my formulas, the angles must be in radians. Okay? And if you want to know how big a radiant is pretty big, because 1 radiant is 57.3 degrees.
3.14 blah 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 equals 5.
3.14 radians equals 180 degrees. 6.28 radians is 360 degrees. So if 6.28 radians is 360 degrees, 1 radiant is 57.3 degrees. Well, a radian's pretty big. You know, it's a pretty big angle for radian. There's about 6 radians in a full circle, a little more than 6. You're looking a bit confused, I'm not sure why, or maybe you're just tired. Tired? Confused? Both. Questions? Any questions? Any questions? No questions? You don't have to have a question. If you don't have a question, I'm happy with that. Does anyone have any questions before we continue? No? But you look confused. All of you. Okay. You have trust issues. That's okay.
No, we trust you.
Okay. It is true. You can Google it later if you like. 1 radian is about 57.3 degrees. Okay? So, let's have a look at 2 examples. It's 57.3, but if you want to be more accurate, you can use this number. Okay? But this is about 57.3, but if you want to be more accurate, you can use 180 over pi. In the exam, they don't really mind. You could use 57.3 or you could use this. They're not, it's not a big deal. You could use 57.3 or 180 over pi, yeah.
Yeah, I mean, we leave the pi. No.
Oh no, with the pi, like 180 over pi. Yeah. Don't worry, it's only a bird. Nobody's coming in to kill you, it's fine. Okay, let's have a look at an example. Can I continue? Next slide? Yeah. So, 0.75 radians into degrees. Okay, let's do that one. 0.25 radians. Well, how much is 1 radiant? 1 radian is 57. 180 over pi degrees. So that equals 14.3 degrees. Or, if you want to use the decimal, that's roughly 0.25 radians. Well, not roughly. Roughly 0.25 times 57.3 degrees. So let's just see what I get if I do that. I said 0.3, didn't I, or 0.1? I don't remember. 0.3? 14.3. You get the same answer. Yeah? Now the next one, 30 degrees into radians. A little bit harder. You basically just divide it instead, yeah. 30 degrees equals 30 degrees, obviously. But we don't like degrees because, I mean, we want to have it in radians, so we need to change it here. Can I scroll down? Yeah. So there's a couple of things you can do here, but maybe the easiest thing would just be to do what did I say? Yeah. 30 times pi over 180 times 180 over pi degrees. Now you might say, why did I just do this? I mean, after all, this is 1. But if you look here, what is 180 over pi degrees? What is this here? That's a radian. So you can change this into radians. So you said you could divide by 180 over pi, which is the same as multiplying by 180 pi over 180. Now I know you probably don't like me doing it this way. That's okay. You can just do exactly what you said, divide. If you don't like that, maybe you'll prefer this. 30 degrees is equal to 30 over 57.3 degrees times 57.3 degrees. Okay, but what is 57.3 degrees? A radian. So this is 30 divided by 57.3 radians, because this is a radian. So this is a little bit like what you were suggesting about dividing. Anyways, it doesn't matter which way you do it. You'll get the same answer of 0.524 radians. Now, again, don't worry, because you will have a lesson on this in math class. So you're actually going to study this twice, but in math class you will study it in more details. So you're not expected to get it all right now. Continue? Yeah? Okay, so next. We've seen two types of motion so far. The first one is motion in one dimension, and the second one? Yeah, motion in two dimensions. Could you actually open the windows there? It's getting a bit warm beside the projector. I think we need full power. Put the air conditioning to maximum, thank you. Okay, so we've seen two types of motion. Motion in one dimension and motion in two dimensions. But what we're going to look at now is a new type of motion in two dimensions called motion in a circle. So firstly, what makes motion in a circle? So if something is moving in a circle, does anybody know why? Like, what can make something move in a circle? So we saw in one dimension it can move forward because there's an acceleration. And what makes an acceleration? A force. And in two dimensions it can move like this. Why? Because there's a gravity. What makes something move in a circle? Yeah, there must be something to do with a center point. What's to the center? Yeah, but give me some word that we've used. Like, I get your idea and that's right, but replace that word held with something else. So it is something to do with the center, and not quite held, but something like this. Getting closer. Yeah? Yeah, pretty close. Yeah, so the reason something is moving in a circle is because there's a force or an acceleration towards the center. Okay? So if something is undergoing circular motion, that means it's moving in a circle, then there's a net force acting on the object, which is perpendicular to the velocity and is towards the center of the circle. So what I mean is, if something is moving in a circle, let's put it here, and let's put the center here, and this is the object. If the velocity is this way, then the acceleration or the force is this way, and these are perpendicular, and this is pointed towards the center. Always, even when it moves. So like here, this is here, this is here, this is perpendicular. Okay, so the force is perpendicular to the velocity, and and it's directed towards the center of the circle. So in the exam, for the definition, they want to see directed towards center, and that it's perpendicular to velocity for 2 marks. 1 mark for this, and 1 mark for this. Okay, so please write this down carefully. Okay, I see writing, that's okay. I'll just check my emails.
Is there a question to write like this sentence?
Oh, of course.
How many?
2 marks.
How much?
From 100 marks.
100?
No, this is 2 marks. If it was an exam question, it'd be 2 marks. The total is 100 marks. 2% of the exam. Is this good or bad?
Perpendicular and direct.
Yeah, 1 mark for saying the perpendicular fact, and 1 mark for saying the centre of the circle fact. Continue, Bruce. What's that? Yes or no?
Yeah.
Okay. Continuing. So, I did the drawing already. A little bit more vocabulary. So when I say centripetal or centripetal, depending on how you pronounce it, centripetal force is a type of force that acts on a body that revolves around a centre. This force contributes to keeping the body in a circular motion. In other words, this force here that makes it move in a circle, we call this the centripetal force. It is the force that acts on the body so that it revolves around a centre, and this force is what keeps it moving in a circle. So I call this force a centripetal force. It's the force responsible for the circular motion. So this is a word you need, centripetal force. Now you don't have to write the definition like this, okay? Because the definition is only to help you understand the meaning. You can write something else, like centripetal force is the force responsible for circular motion. You could write that. Or you could say centripetal force is what makes it move in a circle. You wrote this down? How do you prefer to pronounce this? Centripetal or centripetal? Yeah, go on. Centripetal is preferred? You can say both. If you were to read this, how would you have read it? Yeah, that's fine to say it that way too, yeah. Okay, got that? So next, and again, you know this already, it's acted towards the centre always. Okay, but Newton said F equals ma. And for example, if m is 1 kilogram, then we'd simply have F equals a. In other words, if there's an F, there's an a. And you should not be surprised to know that we have a thing called centripetal acceleration. Guess where that points? To the centre. It's the acceleration that keeps the body moving in a circle. So basically, in the picture here, you have F equals ma. So A equals F over m. So if this is F, then maybe, for example, this is A, because we have A equals F over m. So it too must be towards the centre, and it too must be perpendicular to the V. And it is responsible for the circular motion. So this acceleration, we call it the centripetal acceleration as well. You notice how the definition is the same, except I replaced the word force with acceleration. How come it has 4 lines though? Oh, because centripetal is a longer word than force. Or sorry, acceleration is longer than force. I know. So write something down. You could say centripetal acceleration equals centripetal force over mass. Huh? If you don't want to write all of this down, you could just simply say centripetal force equals centripetal acceleration multiply mass. But you can write this down. I don't know what's wrong with you. What's wrong? Continue? Continue? Yes? Yes? Are you sure? Yeah? Okay. Now, some new words. So we have this thing called angular velocity. I wonder, you might actually be able to figure out from the name. So we all know what velocity is. So angular is an adjective. What do you think the noun is? If the adjective is angular, then the noun is angle. So what could be angular velocity?
Half angle.
Yeah, go on.
Velocity.
Yeah, that's okay. The angle's velocity, yes. In other words, how quickly the angle changes when you move in a circle. The rate of change of the angle with respect to time. So, for example, here's me. I start here, and then 1 second later, I travel 57.3 degrees. Then I would say my angular velocity is 1 radian per second. Yeah, because I travelled 1 radian in 1 second. So it's how quickly the angle changes.
Do they have to change the calculations as radians, or
For these formulas, yeah.
or we just convert?
No, it'd be good practice to change the mode on the calculator. Okay. No, not yet. Yes. No. Bruce? Okay. Yep. All right. The units, of course, are radians per second. It measures how quickly the angle changes, as said. So, for example, the example I gave was 1 radian per second. That is 1 radian per second. Means 57.3 degrees of an angle is drawn every second. The periodic time. Does anybody know this one? No? Yeah, what do you think it is? Yeah. Yes, the time taken for 1 circle, 1 lap. So the periodic time is the time taken for 1 orbit to be completed. Of course, the units are seconds. Got this? Yeah? No? Okay, relax, don't worry. I won't leave you behind this time. Okay. Continuing. So for example, if the t is 2, then it takes 2 seconds for one orbit. Now, the unit per second, we call a per second a hertz. That is, 1 hertz equals 1 per second. So with this unit, we can have this new definition called the frequency, which is the number of orbits in 1 second, and the unit is per second, or the hertz. So in other words, if I say f equals 2 hertz, then what I mean is 2 orbits are completed in 1 second. So you have 1 second and it does this, 1, 2. That's 2 hertz. Or 3 hertz would mean in 1 second it loops 3 times. So hertz means per second, and it's how many orbits you get in a second. So if you could write these down. What if f was half a hertz? What would that mean? Yeah, you only got a half a circle in a second. Yeah, so it would need 2 seconds to complete a circle. Okay, so if you can write these definitions down. Yeah. Okay, got that? Right. Now, just like with our UVATS, we have formulas for all our variables. So the first formula is pretty simple. If I give you the f, you can know the t, or if I give you the t, you can know the f. So formula 1 is the t equals 1 over f, which kind of makes sense, because we were saying if the t is if the f is 0.5, it means in 1 second it does half a circle, so it would need 2 seconds for a full circle, or 1 over 0.5. So there's nothing special about this formula, but it's useful. T equals 1 over f, so that's the first one. Right, what's the next equations of circular motion? So number 2 is if you want the angular velocity. You can get the angular velocity from knowing the time, or if you know the f, because if you know the f, you know the t, and if you know the t, you can know the omega. So the omega, the angular velocity, is 2 pi over t. What would be the formula here if I used f? Omega equals what? 2 pi f, yeah, because 1 over f is f. Is that okay so far? Number 3. If you want to know, now, just to be clear, this v here, we often call it the linear speed. It's how fast it's going in meters per second. So for example, if this was a car, it would be the speed on the dashboard. That's not the same as this one. Okay, so these are different. This one's in radians per second, and this one is in meters per second. So the v is omega or. Now, yes. Yeah, that's all I want to say about that. So v is omega or. Got that? Next one. So, we actually haven't said how you can find the A yet. So, we know that there's an A here. How can we find that? In fact, A is simply V squared over R. If you don't know the V, maybe you can get it from this formula. So that is formula 4. And that is the main 4 formulas.
equals that.
Excellent question. The proof is very difficult.
Very difficult.
Very difficult. But
So just prove.
I'll give you a simple version of the proof. If you look. Can I scroll down? So, think about it like this. If this is moving in a circle, it has an A towards the center. That's the center. So, this A, we know that F equals MA, so the F is proportional to the A. Meaning, if the A is big, the F is big. Okay? So think about it. If you're moving in a circle, what things would make the A bigger? Well, the same things that make the F bigger. So, if you're going fast, do you think that will make the A bigger or smaller? It's bigger, probably bigger, yeah. But we're not sure. Maybe it'll make it smaller, maybe it'll make it bigger. But we feel like the A should care what the V is. But we don't know the power. So we'll put a power here, M. Now what about the OR? Should the A care on how big the OR is? If you change the OR, do you change the A here? You do. Because imagine this. If you're in a car and you're going over a bump and there's an OR here, if the OR is bigger or smaller, can you feel that in the car? Of course you can. In fact, if the OR is smaller, will you feel the circle more or less if the OR is smaller?
No.
You'll feel it more. But if the OR is bigger, do you feel the circle more or less? Yeah, so I do think it depends on the OR. But I think the N, should be negative because it should be in the denominator. And I think the M should be positive. Well, that's what I think. So let's see what we get. If I write it like this, A equals VM over ORN, like that. We can figure out the powers by looking at the unit. So what unit is M? Is A? Meters per second squared. And what unit is the V? Meters per second, but we have M of them? Yeah, so that's obviously a different M. And this one is N. And what unit is the OR? M. Or whatever the N is here. N. So I just cleaned this up. I have meters, seconds squared. And here I have meters, M minus N, over seconds, N. Great. So if you compare them, you can see that the N must be 2 to keep the units the same, because this should be seconds squared. And then what do you know about the M and the N? They should be 1 when you minus them. But you know the N is a 2, so what should this be? 3, shouldn't it? Yeah. I feel like something went very wrong here. Because now I have V cubed over OR squared. That's quite bad. Because I
What did you get the answer?
The 2 minus 1? Which 2? This 2? I got this 2 from here. Saying this is the same as this. No? I told you this was hard. Let's try this again. Yes, okay. A equals V, I don't want to use N. No, don't A. W, that's ugly. Alpha. Or beta. Okay, let's try this again. The units for A, meters per second squared. Okay. The units for V, meters per second. Alpha. Oh, did I forget to do that? Disgraceful. Okay, I got confused. Let's continue. Here, or meters. Beta. Okay, so ms squared equals m alpha minus beta over seconds alpha. So you see the alpha must be 2, and if the alpha is 2, and this together should be 1, then what's the beta? 1. So that means this will be v squared over r. And the reason it's v squared over r is because the units here have to match the units here. Okay, now that's the easy version of the proof. That's not a real proof. The real proof is like 3 pages. We don't need it for the exam. But we can see that it has to be this because this needs to be meters per second squared. Now you might say, well, what if there's a 2 here? Is it still meters per second squared? Yeah, of course it is, even if there's a 2 here or a 3 here. So it's not a real proof, because we don't know if there could be another number here. It's a fake proof. But you wanted some kind of proof, so there you go. Right, let's have a look at some examples now of using these formulas. A CD, which you might remember if you talk to your parents. You know CD? Yeah, okay, good. It spins at 500 RPM. Does anyone know RPM? Oh, give me real words, please. What's RPM?
The balance.
How many times?
Yeah? It what?
Rotations
Rotations
per minute.
per minute, yeah. How many times it turns in a minute?
Yeah.
Yeah, that's what I said. Yeah, okay. So, 500 RPMs. That means in a it turns 500 times in 1 minute. Okay, I'll give you a moment. I want you to calculate the omega. I want to know what the omega is. Try. Finished? You did this one, Bruce? Can you give me a real number that's not in your head? Thank you. Oh, the formulas, these? Did you not write them down? Oh, quickly. 3. Yeah, well, it's actually the frequency, but in the wrong units. Because frequency is how many cycles per second. This is actually a frequency, but in minutes rather than seconds, so you'll need to convert it. $52.3 something as the answer? Don't know, could be. What did you get? Nothing. What?
0.87 AX.
That's way too small. 57 sounds kind of big. Because think about what you're saying. That's 57 radians in a second, which means it turns 9 times in a second. Well, actually, no, it could be that. No, I apologize. It could be that. Let's have a calculation. So what is this 500? That's an F. You have F equals 500 per minute. But we don't want per minute. We want per second. So this is 500 times 1 over minute, which is 500 times 1 over 60 seconds, which is 500 over 60 per second. What's that? 25 over 3 per second. What's that? 7 No, 8.333 per second is the F. So the T is, what was I asking for? The omega, wasn't it? So omega equals 2 pi over T. Yeah, I need to know the T. The T is 1 over F. I can do this. Let me think, 0.12? Is that right? Yeah, I hope so. The omega is 2 pi over T, 6.2830 over 0.12. Let me think. Don't ruin my surprise. Too tired now. $52.4. Roughly. I did a lot of this in my head, okay? Roughly. Did anyone get an answer close to this? Good enough. What did you say you got? Yeah. Anybody else? Not 0. What did you do wrong?
The minute I changed it to hour.
Oh. Yeah, wrong direction. Needs to go to seconds.
Yeah.
Okay, continue. Is this okay? Make sense? Let's have a look at the next one. A car takes 5 seconds to drive around a roundabout of 6 meters. How fast is the car traveling? So, here is our car, and it goes like this. And this takes 5 seconds. And the radius here is 6 meters. And I want to know what is the V of the car. How fast is it going around the roundabout? So I think you can do this. Have a look at your formulas. You have T and you have OR. You should be able to get V. Give it a try. Okay, you got an answer? Yep. You got an answer? Yeah. Over here? Yeah, let's have a look. So, we have B equals omega OR. Great, we know the OR, but do we know the omega? No. But omega is just 2 pi over T, OR. Do we know the T? Yeah, and the OR? And the 2 pi. So what's that? 6.2830 times 5 over 5. So the answer is 6.28 meters per second.
R equal to 5.
Doesn't it?
Yep.
No. Okay, well it's 5 now. Change my mind. It's 5 now. It doesn't matter really. It doesn't matter. Okay, continue. A boy swings a 1 kilogram object around in a vertical circle of radius 2 meters at a rate of 2 hertz. How fast is the object moving? So in this picture here, here's our boy. And he has something here which he is swinging around. And he's doing that at a frequency of 2 hertz. And it's 1 kilogram. And the radius here is 2 meters. My question is, what is the V? V equals what? Okay, try this one now. Let's see if you can use the formulas to get this. Okay? So, V equals omega or. Do we know omega? No. Do we know or? Yes. But omega is 2 pi over T. Do we know T? No. But T is 1 over F. Do we know F? Yeah. So we can say this is 2 pi or F, which will be or is 2, F is 2, 2 for 8 pi, 24.5? No, 25 is it? 25.1 meters per second is the answer.
That's right, 8 pi.
In the exam, they actually prefer you to write this. In the physics exam, they prefer this, and in the maths exam, they prefer 8 pi.
The math will affect the velocity.
Correct. I put that in to trick you. True story. Okay, continue. A 10,000 kilogram plane is banking. Does anyone know what the meaning of the word banking is here? We talk about a plane, not KBC or AIB. It's turning. When a plane goes like this, no, not like this, sorry. When a plane goes like this, we call this banking. When it turns, to turn. That's called banking. So we have a 10,000 kilogram plane, and it takes 1 minute to travel in a circle of radius 1 kilometer. What is the centripetal force? So I'll just draw the picture for you. Here it is here. Here is the plane. That is a plane, I promise. It's very cute, isn't it? It's going this way. Okay, the radius is 1,000 meters, and the mass is 10,000 kilograms, and the time is 1 minute. Okay, so calculate the force here, please. Yeah.
showing the picture.
My beautiful picture. Okay, how are we doing here? Sure. Okay, let's have a look. So, Newton said F equals ma, but we know what the A is. It's V squared over R. Do we know the M?
Yeah.
Yeah. Do we know the R?
Yeah.
Yeah. Do we know the V?
Yeah.
No. So this is M, but V is omega R.
Yeah.
Okay. So that's actually M omega squared R.
Here. Oh yeah.
Yeah, but yeah. Do we know the M?
Yeah.
Yeah. Do we know the omega? No. Do we know the R?
Yeah.
Okay, it's getting better. What can we say about the omega though? The omega is 2 pi over T squared R. So this would be 4 pi squared M R over T squared. Do we know the pi?
Yeah.
Yeah. And the M?
Yeah.
Yeah. And the R?
Yeah.
And the T. So we know everything now. Let's put it into the calculator. 4 times pi times 10,000 times 1,000 over 60 squared. Let's see if you got the right answer. 1 million. No, not 1 million. No, is it? 110,000 newtons about. Roughly 110 kilonewtons. Did you get that? No. That's a yeah, I didn't get it, or yeah, I did get it.
The behind not between.
I want the first 3 digits. Beautiful. How did you do, Bruce? Very wrong?
No, I got 11,000.
Oh, 11,000. It sounds like you lost some zeros.
Yeah.
Continue? Or you need to write this down. Now, some people prefer to do the calculations bit by bit and then get the final answer. That's fine, but I really like doing this because it means my answer will be exactly perfect. There's no rounding errors because I left all the calculations to the end. And it's the way I like to do it. You don't have to do it this way.
Can you please show the calculation?
Yep. Which part do you need to see? Did I miss a zero?
No, I don't know.
Okay, continue. Now, before I do that one, I actually have a second half for this one. So this is me looking at the plane from the top. So it's going around like this, and I'm looking down at it in my helicopter. Now, the second half here, if you look at the plane from the front, so you're looking at it like this, it's coming to you, you're looking at it head on. So, let me try my best. There's the plane. There's the front of it. There's the pilot. Okay, there's the wing. Like this. Because the plane is turning, it's banking. This is like horizontal, and this here is vertical. And if you can imagine, these are the wings here. There's an angle here, and this is called the banking angle. I'll just write B for banking angle. So when the plane is not banking, the angle is 0, because the plane is like this, and there's a 0 here. And then when the plane turns, you get a banking angle here. My question is, what is that angle for this problem? So the problem we just did, what is the angle? I'll give you a little hint. How many forces are on this picture? No, how many forces? How many types of forces? 4 forces? Nope. 2 forces. What 2? Close. Half there. Well, yeah, well, we all agree that there's one force. Yeah, what would you call this now? There's one force, which is the weight. But there's another force here. And this one is called the lift. It's from the wings that help the plane stay up. Yeah, now, this lift, we should resolve it. We should have one component this way. How big would that be? That would be L cos B. And we should have one component this way. L sin B. Now, what do you know about L cos B? Why? Correct, it's not going up or down, so this must be equal to this. And what do you know about L sin B? It's the centripetal force which we calculated. We calculated it. This answer here, this is L sin B. Because this force here is what makes the plane move in a circle. The plane is not moving this way. It's only moving this way in a big circle. Okay, I'll give you a minute. I want the B. L sin B equals the answer you got in the last part. And L cos B equals 10,000 G. 9.81. You have an answer? Of course, your answer should be kind of small.
What's the answer?
The previous answer is about 110 kilonewtons. Kilonewtons.
9.
In fact, this one, believe it or not, you can do it in degrees because this isn't the angle that's rotating around. But if you gave it to me in radians, that would be acceptable in the exam. What did you get?
0.84
Radians or degrees?
radians.
Possibly. Pretty big though, but it could be that. Because that's about 45 degrees.
I got 41.82.
Okay, so it sounds like you got the same answer. Very good. So, you know my style. I like to do this so I can keep all the calculations until the end. Any smart ways to put these together to get just the B? I only want the B. I don't care about the L. If you found the L, fine, but I don't care about the L. Yeah, what could I do? Divide. Yeah, exactly. L divided by L? 1. Sine divided by cos is tan. Answer over 10,000 G. So my B will be tan inverse my answer over 10,000 G. See, it's good to be lazy because then you think of ways not to type much. Answer over 10,000 G. So, yeah. Now you see, your 42 could be fine if... Did you use 110?
No.
You used the answer that was on the calculator previously? What do you get? 0.8 radians?
0.84.
Can you convert that into degrees? See what you get. Multiply by 57.3.
8.1 for 8.2.
Yeah. What did you get?
For 8.188.
Yeah. Well, you got exactly the same.
No.
Well, what did you get?
48.1888.
Okay. Yeah, close. Okay. It sounds like you just have something small mistake because you got 42. Yeah. Can you see anything you mistyped? For example, did you use 9.81 or 9.8 for G?
9.8.
Okay.
But the first answer, the first, was 1.09, 2.2711.
For the force?
The
The F or the L?
No, the Y.
Why?
The answer.
This part? This part?
The A and F.
Yeah. You got...
What was it?
Oh, I don't have it. It was not quite. It was nearly 110, like 109 kilonewtons.
Yeah, so 109.
And did you round that off in your calculations, or you used the full value? Oh, you used the full value? Should have come out the same then. What? I want to know. Now what? Tell me, I want to know. You have the fraction upside down? Yes, okay. Oh yeah, because something interesting about tan actually. If you put your fraction in, here look, this might be useful for you to know. If you put your fraction in upside down, you get the angle but minus 90. So for example, if I take my answer here, oh no! There you go. And if I do 90 minus 48.18, I should get your answer. Yeah. So it was just upside down. Very good. Okay. Anything else with this is okay? Yeah, so there's one more to do. I want you to read this and then try to draw it. But I'll do it. I just want you to see if you can draw this. Let me just actually say something here. Some people are trying a picture, some people are confused. Drew a picture? Let's see your picture. Picture? No.
What?
Why? Oh, no. Picture over here yet?
Yeah.
That's what he drew, no?
In here?
Yes.
Right.
Yes. Shall I draw it? So what you have is, you have a big sphere of radius 5 meters and a ball rolls inside of it, making a circle of radius 4. So, for example, here to here, that's 5 meters, and it's making a circle in the center. And this circle here is 4 meters. So it's rolling inside of a big sphere, this ball. If I look at the picture directly from the side, so here it is here, the distance from here to here is 4, and the distance from here to here is 5.
Why 5?
Because that's the radius of the big sphere. This is me looking at it as it's going around like this. So for me it looks like it's just in a straight line. It's going around in front of me.
But the ball has maybe.
Oh no, the ball has no radius. No radius. Yeah, I don't care about this radius. Yeah. Are we okay with the picture? It's okay or not okay?
Okay.
Try again. No, this is a wonderful picture.
This is 3D.
Yeah, this is 3D and this is 2D. 3D. 2D. The picture's not supposed to be the hard part. The hard part is how fast is the ball moving.
Why should it be there?
Where else could it be? Where else could it be? It's moving around like this, inside. See, the problem is you don't have any imagination because you play too many video games. Now you can't imagine anything anymore. Can you imagine this?
Yeah.
Yes? Some of you I can see can't imagine this. Yeah? I don't have anything to show you what this is. All I can do is with my hand. It's rolling around on the inside of the track. Okay, let's do the question. What is the speed? So, yeah?
At the center, then the radius will be 5.
If it was rolling in the center, then the radius it would form would be also 5. But it's rolling a little bit below the center. So its radius is less than 5. Okay. Continue.
It's supposed to be equal to the linear speed.
Yeah, that's what I'm looking for, the linear speed. Right. Can we know this height?
Yeah.
Yes, what is it?
3.
3 meters. Can we know this angle?
Yeah.
Yeah. I'll just write down, I'll call it alpha. Alpha is tan inverse 3 over 4. Okay, how many forces are acting on this mass?
2.
Oh no, words please, words. I need words.
Weight,
Weight,
then the circular.
not the word I wanted to hear.
Okay.
Yeah?
And then the volume.
Not quite actually.
Then
Remember, just to say, centripetal force is the type of force, but it doesn't provide the force. What is providing forces here? Gravity is providing the force, and what else? Well, I know. I should know. It's my job to know. Do you know?
This is the same as lift or drive.
Reaction force. Reaction force. The force because it's on the surface, like on a table. Now,
Why is it going on?
huh?
Why is it going on?
Why is it like this and not straight up?
Why is it not like this?
Like this?
Yeah.
Well, it could be, as you were saying earlier, if the ball was in the middle, then yes, you would be right. It would be like this. Wasn't you? Was you? Yeah. As you were saying, if it was in the middle, it'd be like this. If it was down at the ground, the reaction would be like this, because, it'd be like on the table. So then if it's somewhere in between, it must be at an angle. In fact, it points always to the center, you notice. Yeah. So, do we know this and do we know this? Yes, this will be or cos alpha and this one here will be or sine alpha. Hey, this question looks familiar. What does this look like? It looks like the question we did with the plane a moment ago. We can say or sine alpha equals mg. What does or cos alpha equal? What does or cos alpha equal? Centripetal force. Well, centripetal force equals ma, and what does A equal? mv squared. The A is v squared over or. So you can replace this because, as you said, it's centripetal force, mv squared over or. What do I want to find from this equation? What am I looking for? The v. Do I care about the or?
Yeah.
Well, I mean, do I need to find the or? No. Do I need to find the n? No. Do I know the g? Yeah. Do I know the alpha? Yeah. Well, I kind of know it here, yeah. So, I can do my trick again of dividing. Or divide or. You see, you might have missed this lesson. This is unstable because your center of gravity is quite high and the base is quite small.
That is so interesting.
Oh, I see. Okay. Or divided by or, 1. Sine divided by cos, tan alpha. M divided by m,
What?
it's gone. Yeah, it's 1. So it's just going to be g over v squared over or. So you can get v squared over or tan alpha equals g if you bring this up. So I'll bring the or up here and the tan alpha underneath. And I'm left with, and then I'll square root it. So this is my v. It's square root g or over tan alpha. But actually, you know what tan alpha is. What's tan alpha here? Tan alpha is 3 over 4. So we know tan alpha. Now, don't just open your mouth. Think for a second. What's the or here? What's the or?
5.
Ah! 4!
Yeah, 4.
Because it's the radius of the circle that it's moving in. So this is, we know, and this we know. So square root 9.81 times 4 over 3 over 4. 7.23 meters per second is the answer here. It's a very difficult question. Very difficult.
For example, the boat goes.
Oh, you really don't like my picture. Yeah, go on. This circle?
We deal with the circle, but the boat.
Yeah. So in fact, we don't really care about the circle that it's in. We care about the circle that it makes.
Why should it be there?
Why not?
Possible to.
Anything's possible. In my question I put it there. You can see why I put it there, because I wanted to make a nice triangle, 3, 4, 5. But I can put it anywhere. I just put it there so that I'd have a 5, a 4 and a 3. No, exam difficulty was, maximum exam difficulty was this one, the plane. This is it's just about exam difficulty, but it would be maximum difficulty, 10 out of 10, maximum difficulty. But as you can see, there's not a big difference between this and the plane example. Or maybe, I don't know, maybe I'm wrong. Do you feel that this is very different to the last example? Yes. Okay. Okay. Okay.
If the ball was spinning around the sphere's circumference, then the radius would be 5.
Yes. But I don't think that's really possible, because there would only the two forces acting on the ball, if it was there, there'd be one force here, which is the reaction, and one force here, which is the weight, and there's no force providing support. The ball would immediately fall. So I don't actually think it could be quite at the height. I think it has to be at least a little bit lower than it. Otherwise it has no up support. It'll just roll straight down. Yeah? Cold?
Yeah.
So cold. Alright, okay. No.
R cos alpha is bigger or smaller than the centripetal force?
No.
Not possible?
No. It's very bad. Yeah, just to be clear in your head, okay? Hey, now this is important. Yes, what are you doing? There's still like at least 10 minutes left. Open up everything. Now, not that, you see, this is one thing that actually confuses students. They almost think like there's two forces. There's the or-cos force and there is the centripetal force. No, the or-cos is the centripetal force. It can never be more or less. It is the centripetal force. There is no such thing as centripetal force. There's only forces which cause a motion in a circle, and we call this a centripetal force. But some people think, oh, when it moves in a circle, suddenly this new force appears called the centripetal force. No, we should think about it like this. Because it's moving in a circle, there's some force making it move in a circle, and we call this the centripetal force. In this example, the or-cos alpha is making it move in a circle, and we call that the centripetal force. So this must be equal because this is a centripetal force, not because it, it's like it or it's,
It's not because it's balanced.
Not because it's balanced, because it is it. Yeah. Okay, and that was a very important question. Right, I want you to try the worksheet for 10 minutes and then you can go.
Is R and centripetal force as well? I mean, is it the centripetal force for the bigger sphere? If there's if it's in the middle.
If it's in the middle, then the or would be the centripetal force. But as I was saying, it's not possible for it to be in the middle because it would fall down. But if it could be in the middle, the or would be the centripetal force.
So the R would be the...
Yeah, and that would be the centripetal force.
What is it like? So
That's that situation we have here. Yeah. Okay, did you write this one down? Yes.
Any some objects moving around.
Yeah.
They have 1, 3 force.
Yeah.
Like 2.
Yeah.
Like in circle.
Yeah.
It's only 3.
If it's moving in a circle?
Yeah.
No, there's only one force. If it's moving in a circle, there's only one force towards the center. Yeah.
They're away.
No, this one looks like there's many forces, but if you look closely, there's two forces, right? This one and this one. But we can break this up into one force this way and one force this way, right? And we have the weight. But if this is equal to this, they cancel, so you're left with only one force. So in other words, if it's moving in a circle, there is only one total force left, the force to the center of the circle. The centripetal force, yeah.
Force. And
All the other forces cancel. Cancel, yeah.
Can you got to your question?
Yes.
But what if it's just the ball is moving vertically?
I think I gave that as a question in the homework.
Alright.
There is a vertical motion one somewhere in there, yeah. Now you enjoy that, please. Okay. Can I close this now? Yeah. Okay. Okay. Try these. Try your workbook questions for a few minutes. Can you put the light on, please?